Hello everybody, how are you doing today? Last time we discussed the characteristics of waves. We looked at the definitions of amplitude, period, wavelength, frequency, and the speed of waves. We say that the amplitude of a wave is the maximum displacement of the wave from its equilibrium position or rest position. We also looked at the wavelength or length of a wave. The length of a wave when it makes a cycle. That is the distance between the successive crests or the successive troughs of a wave. We say that period is the time taken by the wave to make a cycle, a complete oscillation or vibration. The time taken by the wave to make one cycle. We also say that frequency is the number of cycles or number of oscillations or vibrations per unit time. Okay, so today we are going to be looking at the calculations. Like I said, that the speed of the wave, we said, is given by this formula, distance over time, which is equal to wavelength, that is distance for one cycle, all over period, that is time for one cycle. And this also is equal to frequency times wavelength, where the frequency is equal to 1 over period, that is the reciprocal of period, and the period is 1 over frequency, the reciprocal of frequency. So let's move straight to the examples. Example 1. The wavelength of a water wave in a ripple tank is 0.080 meters. If the frequency of the wave is 2.5 hertz, what is its speed? So we are going to list out the parameters. The wavelength is 0.08. The frequency is 2.5 hertz. What is the speed? So listen at the parameters. This is wavelength, 0.08 meters, frequency F, 2.5 hertz, and the speed or the velocity is unknown. So the formula of speed that suits these parameters listed out here is speed is equal to frequency times wavelength. And if we substitute the values, frequency 2.5 times wavelength 0.08 multiplied into V is equal to 0.20 meters per second, which is the speed. Okay, let us look at another example. The distance between successive crests in a series of water waves is 4.0 meters, and the crests travel 9.0 meters in 4.5 seconds. What is the frequency of the waves? The distance between the successive crests. I told you before that the distance between the successive crests is known as the wavelength. It is the same thing as the distance between the successive troughs. The wavelength is the distance traveled when the wave makes a cycle, a complete cycle, or the distance between the successive crests or trough or the distance between two positions, 2 points that are in phase on a wave. So, if we list out the parameters, 9 meters here is the distance, just the common distance traveled by the wave. 4.5 seconds is just the time taken by that wave to cover these 9 meters. This 4.0 here, distance between the successive crests, which is the wavelength, lambda. And we are looking for the frequency. So, listen out the parameters. Distance 9 meters, time 4.5 seconds, wavelength, distance between the successive crests 4.0 meters, frequency is unknown. So the first thing we do here, remember the formula that we are going to use, we have wavelength and frequency. So speed is equal to frequency times wavelength. But looking at this, you will notice that the speed or the velocity is unknown and frequency is unknown also. But we can solve for the speed using these two parameters, distance and time, these two. So if we use the formula that speed is equal to distance over time, change in distance over change in the time. So speed is equal to distance, 9 meters, divided by time, 4.5 seconds. And if we do this, 9 over 4.5, our value becomes 2.0 meters per second for the speed. So speed is now 2.0 meters per second. So from here, we are looking for the frequency. Make frequency the subject of formula. When you do that, frequency is equal to speed over wavelength. From here, if you make F subject of formula, you divide both sides by wavelength, this over wavelength, this over wavelength. So the frequency becomes speed over wavelength. And we substitute the value. The value of speed, 2 meters per second, over the value of wavelength, 4. So 2 divided by 4 gives 0.50 Hertz. Therefore, my frequency is 0.50 Hertz. Okay, let's solve one more example. Example 3. The period of a sound wave from a piano is 1.18 times 10 raised to the power minus 3 seconds. If the speed of the wave in air is 3.4 times 10 raised to the power 2 meters per second, what is the wavelength? What is its wavelength? So the period is 1.18 times 10 raised to the power minus 3 seconds. Seconds is the unit of period. The speed is 3.4 times 10 raised to the power 2 meters per second is the unit of speed. What is its wavelength? So we list out the parameters, list them out. Period is this. The speed is 3.4 times 10 raised to the power 2. The wavelength, lambda, the wavelength is what we are looking for. So the formula of speed that suits this, when you have period and wavelength, speed is equal to wavelength over period. I give you 3 formulas for the speed. So from here, we are looking for wavelength. So cross multiply to find wavelength. Wavelength becomes speed times period. Speed times period. So if you substitute the values, value of speed is 3.4 times 10 raised to the power 2 times the period is 1.18 times 10 raised to the power minus 3. Multiply this 2, your answer becomes 0.40 meters, which is the value of the wavelength. Therefore, the wavelength is 0.40 meters. Okay, so over to you. I'll be giving you questions. questions, about 8. You have to solve these questions, and you send your solutions, your workings, via Telegram to me. I'll be reacting on them. So these questions, this assignment, I'll be sending it via your Telegram, the Telegram group. So you go in there and check for the assignments, and then you solve and send your answers back to me. So in our next class, we'll be looking at the properties of waves. We'll be looking at the reflection, refraction, diffraction, interference, and polarization. Thank you for listening and viewing. God bless you. See you next time.
May it be